Hi, good afternoon, good evening, good morning, or whatever time it is for you when you're watching this video. So we're going to be looking at inverse functions. And you've done this before. You actually did it in Algebra 1. When you were asked to find the inverse of a function, you were probably given it as a table or something called a mapping. And basically, you are switching the x and y coordinates, and we will graph them, and we will also do them algebraically. So there's a few things you need to remember about inverse functions other than just switching the x and y coordinates. You need to remember that the graph of an inverse is a reflection over the line y equals x. So that is your diagonal with the slope of 1, it goes to the origin. So the graphs are reflecting over that line. If you fold your paper or fold the graph over that line y equals x, all the points will match up. Also, there's going to be a new way that I'm going to teach you about proving if a function is an inverse of another function. And we do that using compositions. So that one's here, right here. This is where we're going to use compositions. And when I ask you, hey, is f of x an inverse of g of x, I'm not asking you to find the inverse of each one and see if they match up. What you're going to do is use compositions. And when you do the compositions, your answer simplifies to x. And so it's very important that you know how to do that substitution. And also, we are going to determine if inverses are functions or not. And to do that, we will do something called the horizontal line test, not the vertical line test. Obviously, the vertical line test tells me if a graph is a function or not. But if I also do a horizontal line test on that specific graph, you're able to tell me if the inverse is a function as well. So these are the key points that we need to focus on again. And you've done this in Algebra 1 and Algebra 2. We're just using new functions, new parent functions like rational functions, which are the most difficult ones, but maybe cube roots or cubics. In Algebra 2, you strictly did linear and quadratics. So there is a couple new vocabulary words. Well, horizontal line test, I guess, is a new vocabulary word. But the other one is called one-to-one. So if something is called one-to-one, what that means is the original is a function, and so is its inverse. Okay, now if you think about a quadratic for a minute, let's say you have a quadratic, all right? That is a function because it passes the vertical line test, right? You draw your vertical lines, it only hits the graph on one spot. However, when we go to do the inverse, if I do a horizontal line test, see how it hits in two spots? That means the inverse is not a function. And we didn't even have to graph it to do a vertical line test on it. To say that, I can just do a horizontal to prove that it's not a function. So when the original and the inverse are functions, it is called one-to-one. So if I have a line, for example, just any kind of line that's not horizontal or vertical, this line passes the vertical line test and the horizontal line test. Therefore, this is one-to-one, and we write it like a ratio. Okay, so we're gonna just do some examples whether something is one-to-one or not, and basically we are testing the graph with both the vertical line test and with both the vertical line test and the horizontal line test. So if I look at this absolute value graph, look at A. That is a function, right? However, when I draw a horizontal line, it hits twice. So this is not one-to-one because it fails the horizontal line test. That means the inverse is not a function. Okay, B. That is a function. This is a rational function. Actually, this is, what would this be? This would be y equals -1/x, right? There's a reflection there. But that passes both the vertical line test and the horizontal line test, so this is one-to-one. C. This looks sort of like an x to the third, I guess. It looks a little bit like a cubic. But this passes the vertical and horizontal line test, therefore it's one-to-one. and D. D is a function. However, it fails. This is, what would this be? This would be like, looks like it won't, maybe, well, we don't really know. I was going to say this is a upside down quadratic, but it looks like it might have gone like down 1 or something like that. But anyway, because it fails the horizontal line test, this is not 1-to-1. Okay, so one more time, for a function to be 1-to-1, its inverse must be a function also. So both have to be functions. Okay, so I'm going to give you some examples of just finding the inverse. The notation we use for inverse is f with a -1. And so all you guys are going to do here is switch the x and y coordinates. So this is like an algebra 1 problem. Oops, that's a 0, 2. Okay, so the domain, we're just going to list them. Order doesn't matter, but if you have something that repeats, don't repeat the number in your list, but order doesn't matter. The range 4, 8, 2, -3, 0. So it's just listing the domain and range. That's what DNR stand for, right? Domain and range. So notice that when we do this, the whole point of this kind of real simple example, so I'm writing really fast and just really messy, is that they're switching. Okay, see how we switch the domain and the range? Okay, all right, so next we're going to go to the next page. Notes are very pretty short on this one today. So algebraically, we're not going to work on the graphs right now. We're just going to do algebraically. So what we're going to do is we are going to practice switching x and y and getting y by itself. First of all, this first one is just a simple old line, right? If we were to graph it, it would be something like here and up 2 over 1, up 2 over 1. Sorry, that's super messy. But you can see that this is 1-to-1, right? Passes the vertical and the horizontal line test. This is a simple old line. This is all real numbers. No asymptotes, no funky things going on, right? Now, what is the equation? So this is asking for the equation of the inverse of f of x. So what you're going to do is you're going to switch x and y, and then you have to get y by itself, which is pretty simple in this problem. We're going to add 3. And then we're going to divide by 2. And because I know that the inverse is also going to be a line, let's go ahead and write, let's go ahead and write this as slope-intercept form. Okay, so you divide everything through by 2. So this is 1/2 x plus 3/2. All right, so that's just another line, and the domain and range is all real numbers. Okay, so now we're getting into a little bit more tricky parts here. I'm also going to talk about the graphs, because I think sometimes the graphs help you get the domain and range. So if I have the square root of x, right, that's just a positive square root of x, so 1, 1, 4, 2, 9, 3. So it looks something like that. The domain and the range is 0 to infinity on both parts, right? Now, I could answer domain and range right away because I'm just switching the domain and the range. So this is going to be 0 to infinity, 0 to infinity, right? All right, let's take a look at this, however. We're going to switch x and y. Now, how do I get rid of a radical, right? I'm going to square both sides. So I get y equals x squared. So what's up with that? Because I know that this quadratic is supposed to look like this, right? Well, it's supposed to look better than that, but it's a quadratic, right? However, because my domain and range are 0 to infinity, we actually only want the positive part of this, okay? So when we go to graph this, we really, let me just straighten this out. We just want the 0, 0, 1, 1, 2, 4, 3, 9. You only graph half of it. All right. So we're not even worrying about the graphs right now. But one of the things you need to understand is we are only doing we have restricted this to 0 to infinity. This domain and that range have to be the same. Okay, so we're not going to graph the full x squared. Okay, so that's how you do it algebraically with just a couple examples. Next is going to be deciding if a function is one-to-one or not. And we are working with functions, so we have to be really careful about this. We're very obsessed with functions, meaning we want things to pass that vertical line test. So let's go ahead and talk about this particular graph right here. Let's go ahead and graph it right here. All right, so it says x squared plus 4. So we go up 4. This is review from your transformations, right? Up 4, and then we have this parabola. Okay, is this function one-to-one? The answer is no. Let's see, right here. No, because the inverse is not a function. How do I know it's not a function? Because it doesn't pass the horizontal line test. Okay, so you need to probably write both of that, I guess, but it's not one-to-one because the inverse is not a function. The inverse has to be a function. They both have to be functions. Okay, what is the domain and range of this function? Well, the domain of a quadratic is all real numbers. And the range, sorry, it's supposed to be a bracket, is 4 to infinity. Okay, no questions about that, right? I mean, that's just a simple quadratic. It went up 4, so domain and range. We're not even talking about inverse yet. This is just talking about x squared plus 4. Then part C says find the inverse of the function. All right, so we are going to switch x and y. Don't change anything else. You're just switching the places of x, making y x and making x y. We're going to subtract 4. And then we are going to take the square root of both sides. And remember, guys, when we take a square root of both sides, it's plus or minus. Okay, so that's the equation. That's supposed to be a y. So that's the equation of the inverse. And it says, what is the domain and range of the inverse? Okay, well, think about what a square root looks like, right? A square root, the square root of x minus 4 is right 4. And here's the positive. And there also is the negative. So it looks like this. Oh my gosh, that's so bad. Okay, be patient with me. That is so horrible. I can't have that on the web. Sorry, I have to do that again. Sorry. That is not that much better. So the domain is bracket 4 to infinity. And the range is negative infinity to infinity. Right? We good? Notice the domain and range are completely opposite of each other from the original function, right? Now, it says if we desire the inverse to also be a function, we must restrict. It's supposed to say restrict the domain of f of x, otherwise known as the range of f of x. So when we do that, what we're going to do is we are going to keep the top half. We don't have to restrict it to this, but it's usually we keep the positive. Okay, so basically the range is now 0 to infinity if we want to keep this inverse to be a function. Okay, we will restrict it. Now, this only is going to happen with our absolute value graphs and our quadratics. Okay, the cube roots are fine, the cubics are fine, the rational functions are going to be fine. It's the ones that aren't one-to-one. Okay, All right, so, and I'll show you a couple of other examples on another worksheet. Okay, so verifying inverses using compositions. So this is something that you're going to have to practice. And you, like if we were in class, I insist that you guys are showing your work on this. You can't, I don't want you to find the inverse of each of these and see if you get the answer. You know, I want you guys to use the compositions. So you are going to prove, and this is on your homework. Sorry, I can't talk and write at the same time. You are going to prove that f of g of x equals g of f of x equals x. You are going to prove you get x, and you have to do both. So I'm going to draw like a little line right here. The first one I want you to do is you're going to do f of g of x. Okay, so you're doing compositions just like you did last session. So you're going to grab g of x, all of it, and you're going to plug it in for x. Notice those 4's are going to cancel each other out when you go to multiply it, and you get x plus 5 minus 5, which is x. So verify, when something says verify, that means you're assuming that it's true. You're just showing that you do, that you are getting the x when you do the compositions. All right, next you're going to do g of f of x. And this is where you're going to grab f of x, the whole thing, and you're going to put it into x into the other function. So you're going to do 4x minus 5 plus 5, right? You're taking this whole thing and you're putting it right here. Over 4. The 5's cancel, and you get x. So you have verified that, in fact, they are compositions of, or excuse me, they are inverses of each other because they're compositions. Each of them, you get x. Okay, so what we're doing is we're verifying if the functions are inverses of one another. And you do this by compositions. Okay, and every time I want you guys to write this composition. Okay, all right, here we go. We're going to grab g of x and we're going to plug it in for x. What happens to the square root when you're squaring it? It pops off and you get x. Here we're going to grab f of x and put it into the g function. And you need to show your work. Okay. All right, so that's the notes for now. And I will come back with a couple more examples. Okay, so this next page, these, I don't know, 5 or 6 examples will help you be able to complete your assignment for this week. Your assignment looks very similar to this, and you can use these examples to help you go along the way. All right, so here is another one, another example where you're to be using compositions to prove that these are inverses of each other. So just like we just did the last example, you were going to prove that f of g of x. So we're going to do this first, f of g of x. You're going to take g of x, and these are much harder. Okay, that's why I'm giving you this example. So you're going to grab all of g of x and put it into both of those x's. So you're going to have fractions over fractions. Okay, so there's the top over 1 plus x over 1 minus x. All right, so we're going to need a common denominator. Oh, on the bottom, I should, down here. So I'm going to go ahead and go horizontal. Okay, so this is going to be 1 minus x over 1 minus x plus x over 1 minus x. I don't know why. Sorry. Don't know why I had that extra bar there. Okay, so we're going to put this together. So this is x over 1 minus x divided by, This is an x here. This is the denominator. Okay, this right here, it turns into that, right? 1 minus x over 1 minus x is 1. So we have the x's cancel here, so we're going to have 1 over 1 minus x. Change it to multiplication. I'm going to come way up here. X over 1 minus x times 1 minus x over 1. And notice the 1 minus x's cancel each other out, and you're left with x. All right, I knew I should have given myself more room for this. All right, so let me start over here. So this one I'm going to do g of f of x. Sometimes when we do these, one is easier than the other. Let's check this out. We're going to grab f of x and we're going to put it into the g function. So this is x over 1 plus x all over 1 minus x over 1 plus x. You got to make sure you're plugging in for both of those. All right, so I'm going to go horizontal. So x over 1 plus x divided by, I need a common denominator. I did it again. I need a common denominator here, which is 1 plus x sorry. Still division. I haven't done anything yet. Notice the x's cancel. Right? These x's cancel each other out. And these guys cancel out, and you're left with x. Okay, so again, that was super messy, but hopefully you're able to follow that. If not, just rewind it and go back and check it out. All right, so the next examples are just way more difficult than just working with lines and quadratics. Here we're going to be finding the inverse, and we're going to be stating the domain and range of each. Okay, so let's get started here. This is a quadratic. Excuse me. Sometimes you may not know the domain and range right away. I know that a domain of a think about this as 1/4 x squared minus 5/4. That's the way I would look at that. Like, just split it up into, divide by 4 on each one, so you get 1/4 x squared minus 5/4. So I know I can answer this without even knowing what the inverse is. Okay, so and we'll worry about restricting that in a minute. The range of this goes down 5/4. So this is negative 5/4 to infinity. All right, so let's go ahead and switch x and y, and let's find out what this inverse is. So x is y squared minus 5 over 4. Okay, I'm going to multiply by 4. We're going to add 5. And then we're going to take the square root of both sides. We can't take the square root of anything inside there. So there's our answer for the equation. Now, let me ask you a question. What if you did not understand or know what the range is? Like, you should know that the domain of that is all real numbers. But what if you didn't understand that the range was negative 5/4? Could we come over here and, you can see how this is building on previous units, right? When we did domain, not units, but sections, right? We know how to do this. So x is greater than or equal to 5/4. So we actually could have found the domain of the inverse and then plugged it in over here for the range of the original. So this is negative 5/4 to infinity. Now I do want to mention here that if this is a quadratic, and if I wanted this to be a function, clearly this is plus or minus the square root of 4x plus 5. This graph it goes left. I don't know, let's just say it looks like that. Okay, so it doesn't really, it's not a function, so it's not 1-to-1. But if I said, I need you to make this 1-to-1, you would take off the bottom part. So you would literally make this range 0 to infinity if you wanted to restrict it. I don't ask you to restrict it in the future, but just in case you wanted to know. All right, let's keep going. These are getting progressively harder. Okay, so what is the domain here? What can't X be? Again, this is building on what we practiced with domain. You can't do this if you haven't gone back and done week 4. Week 4 was on domain. X can't be 0, right? So it's everything but 0. And the range, we don't know what that looks like, so let's hold off on the range. We're not going to answer that. But I do know I can come down here and do that, right? So we don't know what this looks like as a graph, so let's not worry about it. Let's see if we can, let's find the inverse equation, and I bet that we can find the domain of that really easily. Okay, so let's switch X and Y. Okay, so this is a little bit, you have to follow the steps, and it's the same steps. Students really struggle with this type, and if you notice, I have a couple more examples very similar to this. Students really struggle with the algebra, so it's the same step every time, same 3 steps basically. All right, so you have to get this y out of the denominator. So you're going to multiply both sides by y. Now, you have to get your y's on the same side. So if you follow the steps, just follow it every time the same way, and you won't struggle. So you're going to get your y's on the left-hand side. So that means you're going to subtract 3y. It doesn't matter if you do x. Actually, let's go ahead and do that. Order doesn't matter. So let's do xy minus 3y equals -2. Then you're going to factor out a y. These are done the same way every time. So we factored out a y, and now to get y by itself, we're going to divide by x minus 3. And there's your answer. Now, what is the domain? Well, that's easy, right? It's everything but 3. So negative infinity to 3, parenthesis, union, 3 to infinity. Okay, so as far as the algebra, that's the hardest part. So just follow my examples here when you guys are going to do your assignment that you have to turn in. So multiply by y to get it out of the denominator first. Get your y's on the same side. Factor out the y. Divide by what's left inside there, and you're done. Okay, let's do number 4. Sorry, my pen's acting up here. Okay, let's do number 4. Let's see, x can't be a -2. So if you haven't done the domain week, the week that we did all domain, this is going to be a little troublesome for you, I would imagine. So maybe go back and catch up. All right, so now, and I don't know what this looks like, the range, so let's wait and see what our equation is. And therefore we can, I'm going to erase this, sorry, I'm going to need more room. Let's do this. This is x equals 5y minus 1 over y plus 2. All right, so we have to get the y out of the denominator. Now this time we can't just multiply by y like we just did on the previous example. We actually have to multiply by the expression y plus 2. So this is going to be y plus 2 times x. You're going to need to distribute. Now you need to get your y's on the same side and anything else that doesn't have a y on it to the other side. My advice is to just always bring y's to the left, regardless of what the sign of that 5 is. Just bring everything always to the left. Bring your y's to the left and get rid of the baggage to the right. So we're going to subtract 5y. And then we're going to subtract 2x. Factor out a y. And then divide by x minus 5. Now we got a lot of negatives in here. So I will say you are allowed to leave it like this. You're totally allowed to leave it like this, but you can also multiply everything through by -1. It's totally your call. It doesn't matter. So you can leave it as -1 minus 2x over x minus 5, or you can multiply everything through by -1 and get 2x plus 1 over 5 minus x. But everything has to get multiplied by a -1. Okay, so what is the domain? For here, anything but 5. No 5. 5 is no good. That gives us 0 in the denominator. And if I know the domain of the inverse, I know the range of the original. All right. All right, number 5 is a little bit easier, but nonetheless, that you have one on your worksheet that you have to submit that is just like it. So I want to make sure that you have an example of everything. All right, so let's first start. Let's not worry about too much about what the graph is. This does go up to, that will help us with the range. But let's go ahead and this goes left 5. So our domain is a -5 to infinity. This graph goes up 2, and there's no reflection. So this is 2 to infinity. So we can leave it like that. All right, let's switch x and y here. So we get x equals 3 times the square root of y plus 5 plus 2. Your goal is to get y by itself. So you have to get rid of some of this baggage first, right? So subtract 2. And then divide by 3. And I'm not going to split it up this time. I'll just leave it like that. Square both sides. And then you're going to subtract 5. So let's put the answer here. X minus 2, excuse me. Ah, what's happening? Let's try that again. We have, I don't know why I can't write. X minus 2 over 3. All of that is squared minus 5. And you can leave it like that. My answer key, I don't know where my answer key is, but I think on this one, I might have that foiled out. I can't remember. But this is kind of hard to get the domain and range on this one. It is a quadratic, so the domain would be all real numbers, but we've had to, because this right here, that graph is, it looks like that. So you're not going to have all real numbers for the domain, even though that's a quadratic. So you're only looking at the right half of that quadratic. Okay, last example, and we are done with the notes. I appreciate you hanging in there with the video. And again, when you guys are completing the worksheet practice for this, I do have examples pretty much of everything that you have to turn in, and you can also come for help as well. This is asking you to graph f of x and its inverse on the same graph, and then I want you to draw the line y equals x to see the reflection. Colored pencils will be super helpful for this. So let's go ahead and graph x to the third minus 1. We know how to graph that. That's down. Except for my pen is horrible with graphing. So, all right, so we go down 1. That's all there is to it. So we have our 3 ducks in a row. This is a cubic, so 2, 8. 1, 2, 1, 2. All right, so wish me luck graphing this. I don't know why I did that. If we go to distance learning in the fall, I'm going to purchase myself a really fancy pen. This just doesn't work very well, so my apologies. All right, so let's find the inverse function. Switch x and y. X plus 1, right? And then cube root of both sides. All right, so this is a left one. You're going to go left one. And you are going to have 3 ducks in a row. But remember, this is a cube root, so it's flat, right? So 1, 2, 1, 2, 3, 4, 5, 6, 7. I think I counted right. Yeah, 1, 2. Let me double check that one again. Yeah. All right, so let me take a steady hand here, see if I can get this. Oh, that's better. Unfortunately, doesn't look super great because you can't really see that. All right, let's graph the line y equals x. Goes to the origin. Has a slope of 1 over 1. Okay, and it's not, it's a little, if my blue guy was a little bit, or if my red guy was a little bit better. But there's your graph. And it's supposed to be a reflection. So if I have the point 0, 1, 0, negative 1, I should have the point negative 1, 0, right, on the inverse, and I do. If I have the point 1, 0, I should have the point 0, 1, I do. So I'm just kind of checking some of the points. It's just my red graph is so bad. Anyway, so I hope this was helpful, and I hope you guys are well. You're almost done. You guys are doing a tremendous job. Please, please, please try to catch up if you're behind. But you guys are doing fantastic for the majority of you are doing fantastic. So keep up the great work. We are almost done. One more lesson after this one. Hang in there.